Okay, I think we're ready to go here. So, we're going to take a look at first this relation, not a function. Everybody agree with that? X equals y squared is not a function. Okay. One way to tell when you're looking at an equation if it's a function or not is, can I solve it for y and get one answer? And if I try to solve this thing for y, square root both sides. Technically, what you have to do there is do the plus or minus square root of both sides, in which case, as soon as you do plus or minus, you have two different separate pieces. So this is an implicit curve then, okay? And the two implicit functions then that you would have would be the square root of x and the negative square root of x. And what this thing looks like when you graph it is just a parabola on its side. So trying to do the derivative of this thing the way we have been, we can't do it. Because it's not even a function to begin with, so we can't apply all those rules we've talked about. So what we have to do is think y is actually y of x. Okay, that's not a multiplication. It's a function notation thing. It's y of x. Okay, so what we really have here that we're doing the derivative of is x equals y of x squared. Okay, and we're going to have to apply the chain rule to make this thing work. Because I've got this y of x, and I don't know what it is. Okay, at least right now I don't know what this is. Y is some kind of function of x that's been like dropped into this equation that I'm working with. Okay, so if I'm going to do the derivative of it, I can go through and do the derivative of each side separately then. Okay, so anything involving x still works like x, just like we have in the past. And you can do derivatives of x just like we have. So on the left-hand side of this thing, what is the derivative of x? Just a 1, right? Okay, so 1 equals, and then I need to do the derivative of the other side, okay? But that, again, it's this y that I don't know what it is, but think about how we did that before, okay? If I don't know what this is, I still want to do the chain rule with it. What am I going to have to do? It's squared, so what do I do with this 2? Bring that down, right? So I've got 2 times y of x. But the chain rule tells me I need to multiply by the derivative of the inside piece, right? Okay, so what's the derivative of y of x? Just y prime of x, right? That's all I got. That's all I can write. Okay, so now I've got this little equation that involves y prime of x. So if I want the derivative, okay, what I have right here is not technically the derivative. What that's called is the derivative step, but I haven't actually gotten the derivative just yet. Okay, so the derivative is hidden in there. It's part of that equation. It's right here, right? Y prime of x. So I'm going to do a little algebra, and I'm going to solve for that little y prime of x. Get that by itself, and then I'll have y prime of x equals something, and that something is my derivative then that I want. Okay? So if I solve for y prime of x, that just means I need to divide by both of these. Right? I got to divide this whole side by 2, divide the whole side by y of x. So it's 1 over 2 y of x. Okay, or if I keep things simple, I can drop that of x. Okay, I did that to start with here just so you would remember it's a function of x. I need to do the chain rule to get through that. But in practice, what you're going to do is going to be just this. I'm going to do the same problem in this other little column right here, and I'm just going to drop all of the of x's. So you have x equals y squared. So your derivative step would be 1 equals 2y times y prime, and then y prime equals 1 over 2y. Okay, and so this would be your derivative. Now, what do you notice about this derivative that we just calculated that is different from other ones that we've done in the past, like pretty much all of them? What's in our answer on this one that's never been there before? A y. The thing about implicit functions is sometimes you'll have derivatives that just involve x, sometimes you'll have derivatives that involve y, sometimes you'll have derivatives that involve both x and y. Okay? Because to find a derivative along this curve, okay, imagine that this had come out to something that just involved x. And I said, okay, find me the derivative when x equals 2. Well, where's x equals 2 on that curve? Let's say like 2 is right here. Okay, you want me to find the slope of the tangent when x equals 2? So do you want this point or do you want this point? See the problem with that? If I'm given an x value to use for this, I've got more than one point I could choose because it's not a function, right? That doesn't work. So sometimes the derivatives are going to involve a y, or like I said, both x and y. So you literally need to know both coordinates of the point to precisely pinpoint where it is. And where do you want that derivative? So let's say I don't necessarily want it at just when x equals 2. I want to know when it is the point 2 square root of 2. I guess maybe if I did a 4 to start with, that would have been easier. But that makes sense. If this was 2, then this could have been a square root of 2, and it would still technically work. And then I know I'm talking about this one up here, the positive one. If I said, okay, tell me the derivative when it's at the point 2 negative square root of 2, then that would be this one down here, and I know I'm talking about that one. So with implicit differentiation, oftentimes you're not just given when x equals, you're giving an entire xy coordinate pair to plug in. Okay? Or in this case, all I would need is a y, and it would work. Okay? So like for this one, let's say find the equation of the tangent and let's do at the point let's say 4, 2. And we can verify, okay, does this thing actually go through the point 4, 2? X is 4 when y is 2. Does that make sense? That satisfies that equation, right? X is 4 when y is a 2. Okay. Goes through that point. I can take this now, figure out the slope from my derivative. My derivative needs the y coordinate, not the x. So the slope of this thing should be 1 over 2 times 2. So the slope at that point should be 1/4. Okay. So here's my slope. Here's my point. I can do that. So y equals mx plus b. If we plug in, x is 4, y is 2. So then I got 2 equals 1 plus b, so b is equal to 1. So the equation of my tangent line, we'll jump over here, y equals 1/4 x plus 1. Okay, so I can do it. Okay, so let's try another one. Let's get a little bit more complex with the equation we're working with here. I'll show you, because with these, sometimes we'll have some product rules thrown in there, that sort of thing, sometimes some quotient rules, and so we want to be able to make sure we can get through those as well. Okay, so let's say we've got that curve. Definitely not a function. Okay? See how we cannot solve this thing for y? Okay, the y squared kind of gives it away. Can't solve that for y and get one answer. In fact, I'm not sure you could even solve it for y, period. So, we're going to still apply some of the same kind of rules. I'm going to do the derivative of this one, kind of like I did the derivative of the last one, where I'm not going to do the of x anymore. But just remember, every time we come across a y that we want to do a derivative of, we have to think about it as if y was a function of x and do a little chain rule action on it. Okay? So, right off the bat, we've got a product rule, correct? Okay, so I'm going to take the 2 and the x, make them 1, and then the y will be the other little piece. And let's apply that product rule. So, derivative of 2x. Don't overthink it. Yeah, 2, right. Remember, x is all good. You still do it the same way you've always done it. Okay, derivative of that times the other, so just y then, plus the first 2x, and then the derivative of y prime. Now technically it would be 1 and then times y prime, right? If you did to think of it like a chain rule, you'd have to do the derivative of y. Okay, that's just 1, but then multiply by the derivative of the inside part, that's the y of x, so it would be y prime. But, yeah. Or you can just think, which is probably easier, okay, if I have y, what's the derivative of y? Y prime, right? Just think of it that way, it's probably easier. Okay, then the next part, minus, I've got this thing involving y. Okay, so do the derivative of this just as if it was x to start with, okay? What is the derivative of 4y squared? 8y. But y is a function of x, so I need to multiply it by what? Y prime. What you're going to find with this is really, now that I think conceptually we kind of understand what's going on, every time you come across a piece that involves y, you always have to tack on a what at the end? Y prime. Yeah. Okay? Really, that'll get you through it. Every time you come across something involving y, there's just going to be a times y prime on the end of it, because the chain rule little part has to happen for that. If it's x, just same as always, nothing fancy. But the y's always have a y prime there. And then equals, what's the derivative of 0? It's still 0, yeah. Okay, so there's the derivative step, right? We went through and did the derivatives of everything. Now, to actually find the equation we want to use for the derivative, what do I have to do with this? Right, I have to solve this thing for y prime. Okay, so I'm going to just rewrite this so it's a little easier to look at, but then that's going to be our goal, is to solve it for y prime. So, any suggestions about how we might go about doing that? All right, subtract the 2y. Okay. What do you think I should do next? I got a couple of y primes in there in 2 different terms. What could I do to help myself out here? Factor that thing out of there, right. So factor out the y prime. 2x minus 8y equals negative 2y. Okay, and then? You got it. So then divide. All right, and I'm going to rewrite this now so it's a little easier to work with, and see if you guys can tell what I did here. So It was negative 2y over 2x minus 8y, so I'm going to make it just a y over 4y minus x. What the heck did I do there? I took out a 2, and what else did I do? I think I heard somebody else say it. I think it was up here. What did you say? I took out a negative 2, technically, right? So if I divide everything by negative 2, the negative 2y becomes y. The 2x becomes negative x, and the negative 8y becomes 4y. So that subtraction on the bottom then just got switched because of that. But everything they said at negative 2 pulled out and canceled. Okay, tomorrow we'll look at some more difficult ones, and we'll do some second derivatives with these guys too. So please show up tomorrow, though. Sorry.